This is your physics teacher Fakhruddin going to explain a little bit basics about today's chapter so that you can visualize the topics easily. So I'm going to take one example of liquid and gas. You can compress gases but you cannot compress liquids. What is the reason behind that? Because liquids are already very close to each other. The molecules are very close to each other. Their density is constant and density cannot be changed. Now, when you try to compress water like liquids here, it cannot be compressed because the density is constant in water. So further it cannot be changed. Now let's go ahead now. Let us take a gas here. Gas molecules are away from each other. There is a chance of compressing them further. So when you push the piston above, the piston goes down a little bit because gas can be compressed because the molecules are far from each other, and the density of gas is not constant. It can be changed. The density can be increased by compressing the piston of an injection in which gas is present. Hope this is the best example for you to understand this concept. Let us discuss the next topic, which is called as viscosity and viscous forces. In this, let us take an example of a solid in which the molecules are present and there is a strong force of attraction between the molecules, which is also called as cohesive forces. Now, if you heat these molecules, they start vibrating. So the molecule starts vibrating. They start moving related to each other. And when you increase the temperature, the heat energy is converted into vibrational energy. Here, when you heat certain solid, it converts into a liquid. Different magnitudes and relative motions at different places. There is a relative movement between the molecules here, and it is completely depending upon the viscosity. More viscosity, stronger forces of attraction, less relative motion. Less viscosity, weak force of attraction, more relative motion. Cohesive forces means attraction between same type of molecules. Therefore, if you take an example of a oil and water, oil is more viscous compared to water because the molecules are having a lot of attraction force in the case of oil. On the surface, viscous force are less, and inside the surface, viscous force is more. Let us take a boat which is floating, which is sailing on water. When a boat tries to move forward, it tries to take some molecules on the surface along with that. But as there is a strong attraction force between the molecules inside the water, the molecules does not allow easily for the topmost layer of the molecules to move along with the boat, and a force is created between the layers of the molecules in water, and that is called as viscous forces. So boat needs more force to move forward because viscous forces are acting in the backward directions. As viscosity increases, viscous forces are also going to increase. And you should know that liquid flows in terms of layers. If you take an example of oil and water, both has to take more efforts to float on the oil compared to water. The reason is viscosity of oil is greater because strong attraction forces are there in that. Now we shall discuss about what is the meaning of rotational and irrotational fluids. Let us take a substance inside the water. When the water is flowing and it is having a rotational axis, rotational flow, then this is called as rotational fluid. Let's take an example. Example is these are the lines which are very straight. That's why it is called as irrotational flow. And if you take here just above the substance which is present inside the water, Here lines are curved. That's why it is said to be rotational flow. The best example for rotational flow is whirlpool. So, and the best example for irrotational flow is water moving inside the pipelines. Let us take an example of laminar flow or steady flow. So, water moving along with the canal is the best example for steady flow or laminar flow, where the water's having a equal velocity almost in all the points of this canal. Rather than this, if you take an example for turbulent flow, this water which is having a turbulent flow is the best example given in this picture. So the water is not having any straight line flow here. It's